Okay, today we are seeing the examples on differential equation. The topic is that higher order linear differential equation with constant coefficient. So the first example we saw here, the example given to you as d square plus 4 into y equals to cos 2x. So this is the higher order. Why it is higher order? Because order is what here? It is 2. D square is there. Order is 2. What is this d stand for? D stand for what? It is ddx. This is the our derivative with respect to the x. That means our d, it is a, we are using for convenience that d for ddx. So d square plus 4 into y equals to cos 2x. This example we have to solve, and the solution will comprise of two parts, that is a complementary function and particular integral. So our first job is to find out what? Complementary function. So to find out the complementary function, we first of all find out the auxiliary equation for this equation. So how to get the auxiliary equation? I consider a function of d. In this function of d, I replace the d by m. So this will be a m square plus 4 and equate that to the 0. Then this is called as the auxiliary equation. Okay. Now after getting this auxiliary equation, we see that this is the quadratic equation. So this equation will have two roots. Okay. तो इसके हम roots find out करेंगे. तो for that I take that to the minus 4 to the RHS part, take a square root. Then square root will be this plus minus 2y. Okay, this can be written as 0 plus minus 2y, is it? Because there is no term here, so we can put the 0. Then this I equate to what? Alpha plus minus I beta. So alpha will be what it is? 0. Then beta is what it is? 2. Okay. So I just have the CF for the imaginary roots. It is e raised to the power alpha x c1 cos beta x plus c2 sin beta x. So alpha I put as what? 0. Beta is what it is? 2. Okay. Putting that value here, we have this one, and we know that e to the power 0. What is it? 1. So just escaping this one, this I write down here, then c1 cos 2x plus c2 sin 2x. Is it clear? The roots are plus minus 2y. This CF will be c1 cos 2x plus c2 sin 2x. Now after that, next job is to find out the pi, which is called as the particular integral. So the pi will be given by the formula 1 upon the function of d. The function of d we are having as what? D square plus 4. So that we have written here d square plus 4 into the RHS part of the equation, that is cos 2x. If there is no RHS part, so there is no need to find out pi. Then CF will be our solution, itself a solution. So यहाँ पे RHS part non-zero नहीं है, sorry 0 नहीं है, it is a non-zero, it is a function of x. That's why we are finding it is particular integral. Now in this case, now after writing this quantity, I have to convert the denominator as a function of d square if it is not there. But here d square is present. Okay, because whenever we deal with the sin and cos case, so that time we are having the pi as it is function of d square is here in the denominator with a sin x or it is cos x. So in this case, I replace this d square by what? Minus a square into it is sin ax or it is cos ax. Okay, same case will apply here. We are having a cos 2x, so I replace the d square by minus a square. If you compare the cos 2x with cos ax, that a is what it is? 2. 2 का square 4. 4 को minus से multiply करेंगे, it is what? Minus 4. Okay, so then d square will be replaced by minus 4. Okay, this minus 4 plus 4 is what? 0. So 1 by 0, which is not defined, it is infinity. So that's why we write down here case fails. Now whenever the case fails, so this is not the pi, our required pi. There is another way to find out the pi then. Okay, what we do then? I multiply to the left hand side by independent variable, it is x. Then take the derivative of the denominator, that will be 2d plus 4. With respect to the d, you have to differentiate. Okay, that will be 2d plus 4. Sorry, 2d plus it is 0, the derivative, and this 1 by d stand for the integration with respect to x, because I have mentioned here d stand for what? Derivative with respect to the x. So hence by the definition 1 by d stand for, it is a inverse, 1 by d stand for the integration with respect to the x. So I do the integration of cos 2x, and that is sin 2x by 2. So it will be now x by 4 sin 2x. This is the pi. I combine the complementary function and the particular integral to get the final solution, that is called as the complete solution. So complete solution is y equals to CF plus PI equals to, then you have just written here CF and as well as the PI. Okay, this gives the solution to that differential equation. If initial conditions are given to you, that time you have to calculate the value of arbitrary constant, that is C1 and C2. इसके वैल्यूज निकालने पड़ेंगे. अब यहाँ पे कंडीशन नहीं दी है, so will not calculate. This is our required solution. Okay, solution I have told you many times that it is a relation between the dependent and independent variable which satisfies given differential equation. Okay, thank you.